Hello, everyone, and welcome to today's breakout room regarding flexible production systems for competitive manufacturing. I am Loris Valero-Lepont, and I am the research manager at EIT Manufacturing. And I'm really pleased to welcome you today to this breakout session with all the different activities that will be presented. So, for the first presentation, I will introduce you to the RIS-Hubs activity that I'm managing. This activity is the cement of the communication and the dissemination of EIT manufacturing activities and of the communication in general. So, as part of the RIS Responsibility Innovation Scheme, the purpose is to really help and develop the innovation in what the Innovation Scoreboard calls emerging innovators in Europe by providing them specific funds and allocate them specific activities for their development. So with our current 12 partners disseminated all around Europe, Central Europe and Southern Europe, we are all working in Europe in order to develop manufacturing and innovation in those countries, with many various activities implementing the integration of the knowledge triangle, so education, business creation, and innovation. But enough talking about EIT manufacturing activities. Let's talk about the other and all those related to flexible production systems for competitive manufacturing. And I would first like to introduce you to AAS Hub. We are still having the topic here with Mario Wolf. Mario.
Yeah, thank you for your introduction. My name is Mario Wolf. I'm a senior researcher and developer at University Bochum at the Digital Engineering Chair, and I will present to you the AAS Hub project, where Contact Software is the business champion, and Prima Industries and the Bollhoff Group are our application partners. AAS Hub is not only a great name if you want to be first in line in alphabetical order, but also because it's a two-part composite. It's AAS and Hub. Okay, this is obvious. But what is AAS? It's the Asset Administration Shell, and it's a current project running around the whole Industry 4.0 initiative. And the idea is that the Asset Administration Shell basically bundles everything together that a digital twin needs to describe a physical asset. And this is a good thing, obviously. This is what we want in a digital transformation. But the Asset Administration Shell relies on having this physical counterpart. So it's really the, let's say, digital description of a physical counterpart. And in our quite lengthy title of our project, we want to accelerate IoT integration through this Asset Administration Shell. The Asset Administration Shell is standardized. It's standardized by the Industrial Digital Twin Association. And it's standardized, sorry for that, both in its structure and its interchange format, which is the AAS-X format, which is also standardized. The problem with that is it's mostly research at this point, and it's not really available in industrial software. We wanted to change that, and especially Contact wanted to change that and implement it into their ecosystem of PLM, IoT, and now the digital twin compatible thing around the Asset Administration Shell. The initial idea was that you should be able to import AAS-X files to get up and running with your IoT implementation as fast as possible. And this was the first goal in the implementation. This goal was met. We validated this with our industrial partners. So we created AAS-X files manually with the editor that allows to create those files, and basically described some assets at Bollhoff's and Prima's factories. We had several use cases around, let's say, more the discrete production processes as well as continuous processes, and we're able to use those manually created files to import them and basically get up and running with your IoT implementation within minutes. And that's the goal of the whole project. But we then went further and enhanced this whole approach by a quite obvious addition, which is the export function. which now offers also within the scope of the project to export AASX files. That's not a small feature because everything you need to do that is basically in PLM and IoT after the engineering phase. So if you're, let's say, a machine tool manufacturer and you engineer your machines, you can now go on and export an AASX file that you then can provide in addition to your physical machine tool. So your customer can import this AASX file, basically just set up IP, protocol, and credentials, and the machine is up and running in your IoT environment. And this is the added benefit we were able to achieve within the runtime of the project. And there are already the first customers of Contact Software that will be basically the first adopters of the real product that is called AAS Hub that is implemented in Contact's elements for IoT suite. If you have any questions about that, feel free to contact me and maybe visit our project websites. That's basically it from my side.
Thank you, Mario. Yes, indeed. Just a tiny reminder that we do all the presentations and you can ask questions in the chat and we will answer them at the end of the session. So we keep an eye on your comments, we keep an eye on your questions, and once the presentation are over, we will ask them to the presenters. So thanks a lot, Mario, for your presentation. Now I will give the floor to Campus 4.0 with Gernot Mausner. I hope I'm pronouncing it well. So the floor is yours. Thank you.
Super. Thank you so much, Luis. Thank you for the opportunity to present our project Campus 4.0 today in front of that audience, even if it's still an online event here from my side. We are Campus 4.0. My name is Gernot Mausner. I'm with the Institute of Production Engineering at TU Wien. And together with our project partners, the Faculty of Mechanical Engineering in Prague, as well as the software company Modelworks from Germany, in Aachen, we developed an individualized and specialized training program focusing on CAD/CAM and simulation technologies. Why did we do this? There is just a huge lack of skilled personnel in the industry already today. Companies, especially in the small and medium business area, are looking basically left and right for experienced people in that CAD/CAM and CNC field. On top of that, the development in the last 10 to 15 years, for example, under the name of Industry 4.0, has provided us with many more opportunities, many more functionalities, and many more ideas what we could actually do using those systems in the manufacturing field. But many of those things are not fully developed or not available to the companies, or the companies know of those new opportunities but don't have the trained people to do that. So we decided to take charge and developed a training program focusing on CAD/CAM technologies and on new trends, new technologies, new software that is available already today on the market and you can use. We did here two things. First of all, we developed online content, which is now, since this week, also online available on skills.move, the e-learning platform from EIT Manufacturing, where you have 5 learning paths and 28 nuggets in total, and you can basically and upskill your existing employees in the field. But what we also did, and which is very exciting because we are doing the first workshop next week, is we developed an hands-on live training together with our colleagues in Prague. So companies have the opportunity now to either do a hands-on workshop on those software systems in Vienna in the laboratories from TU Wien, or in Prague at the laboratory of CTU, and you can experience and use the software systems we talk about in the nuggets in a hands-on fashion, and you can see if that would be something your company is benefiting from. Yeah. So with that, we hope we do our part in the and upskilling phase of the European workforce, and I would love to see you very soon in one of our workshops. Thank you so much, Luis.
Thanks a lot, Gernot. Thanks a lot for this presentation. Next, I will introduce you to Dee Hammer, and the presentation will be done by Enrica Bossani. Bossani, sorry. Please, the floor is yours. Thank you.
Thank you very much, Loris, for the introduction, and nice to be here. So my name is Enrica Bossani, and I work for Whirlpool and I am the activity leader of the DIAMER project. DIAMER is the acronym of Digital Human Model for the Ergonomic Workplace, and is fundamentally dedicated to the the creation of an additional functionality to an existing simulation platform that is distributed by Flex Structures, which is one of the partners of the project and the business owner of the final solution too. So create within the current platform, which fundamentally support the design of a workplace and work cycle with an additional functionalities, providing the opportunity to have an automatic assessment executed through the method EAWS, that can be applied, and in order to ensure the creation, starting from the very beginning of the production process design phase, of a workplace that is fit to health and safety requirements for the workers. The project starts from a business needs that Whirlpool, but like other industrial partner or companies may have, to speed up as much as possible the design phase of the production processes. Normally what we do is we start from design, and we design the workplace, the work cycle, the layout of the place, and only after the real mock-up development we can test the ergonomics impact through an assessment. This tool will allow us to have automatically this ergonomics evaluation embedded into the initial phases of the design process in order really to achieve the best combination in terms of work cycle, so list of the tasks that have to be executed, and also layout of the workplace. Strong collaboration with us is provided by Politecnico of Torino, with strong competence provided into the project related to ergonomics methods, and also by ETE, Industria Tecnologica Italiana, which supported us with strong competence in robotics. In the project, we developed the demos, so the use cases, both on human workplaces and on hybrid workplaces, so including also the possibility for us to design workstation where there are collaborative robotics. So in creating a different way to design and define, for example, the hybrid work cycle for a better collaboration between a human and robots. Last but not least, in the project is GVS, who is another industrial partner, and that with us is testing the final solution. I hope you may keep me as a reference for any further information related to the project, either to me or to the business owner represented by Valerio Cibrario, which is shown as reference in the picture that you are seeing. Thank you very much.
Thanks a lot, Enrica. So now we move to Flexi NDT with Gwenaëlle Toulelan and François Cartier. Please, the floor is yours. You're muted.
Sorry. Perhaps now you can hear me. I'm François Cartier from CEA. Thank you for the slide. And the main objective of this project is to develop the new tools for zero defect detection in industrial parts. So in this project, we have 5 companies. 2 business owners who are EcoScan, a French company which is developing and selling non-destructive testing tools. EasyBot, which is building robots, collaborative robots. Two end users who brings us use cases. One is Gualini, an Italian company which is building parts for wind towers. CoExpert, which is a Belgium company which is building composite parts for planes. And two academic companies which are Polimi, Politecnico Milano, and the CEA. So the aim of this project, the issue addressed, is that to bring quality to non-destructive testing inspections is depend strongly on human capacity to make repetitively some inspection actions. And this is a big deal in our industry, as when the operator is tired or anything, some mistakes could appear. So companies need to automatize and to robotize, in some cases, these inspections. But this is a complicated process, as it needs to have specialized operators able to program the robots, the trajectory of the probes on the robots. So the idea was to integrate two new tools in the inspection field. One is ultrasonic phased array technique, which I'll tell you a few words later. And the other one is a specific robot, a robotic arm, a cobot, collaborative robot, which is driven by a pressure. So with this kind of specific adaptability of the robot, it is really easy to program without any knowledge, a trajectory of the probe on any part which non-regular geometries, not plane or cylinder. So this is the main idea of the project, to put together these two technologies and to demonstrate that with these two technologies, it is really easy to make a reproducibility, to bring fiability on the automatization process. So as I said, to be able to guarantee that the product is defect-free is really an essential point for in several industries, and we focused on aeronautics with CoExpert on this part, and also to the metallic tubes which is used to build wind towers. So what we made is to develop specific adaptations between the two techniques and to connect inspection system, ultrasonic phased array system, to the cobot, and to allow in focusing on the fact that we need to be faster than manual operation, and also safer in the analysis of the result as a human specialized people. So we demonstrate that in some case we have a gain of 5 to 10 in speed of inspection on big plates, big parts, as perhaps you can see on the picture on the slide. And we are now working to make a demonstration in Italian Gualini factory, putting together the normal operators and the robot and the automatic system, and to be able to compare that we are able to bring better quality inspections and also much faster inspections on industrial parts.
Thanks a lot, François. But time is running out and we have a tight schedule. No worries. So thanks a lot for this. We will share also the fact sheets with everyone. After this really interesting presentation, now let's move to Gazelle Accelerator that will be introduced by Anne Keroué from Aerospace Valley. So please, Anne, the floor is yours.
Hi, good afternoon, everyone. Thank you for the introduction. So my name is Anne Keroué and I'm from Aerospace Valley. So I will present you today's project Gazelle Accelerator. So it's a project for business creation, and we have different partners across Europe. So we have LMS, RoboHouse, Steve Delft, Atos, FGB, Fast Track and Limpra in the consortium. So the challenge the Gazelle Accelerator project is tackling is that we have seen that there is a lot of SMEs and startups in the manufacturing field. There is a lot of potential for them to grow up, but they are always facing the same issues, that they are lacking of visibility, they are lacking access to the manufacturing industrials network and investors, and it's difficult for them to reach them. So with Gazelle Accelerator, we offer them a support program to really help them to develop their strategy, to develop their pitch in front of the investors and in front of the industrial, to be able really to create effective and long-lasting connection for business and investors. So Gazelle Accelerator started in 2020, and now we are finalizing the sixth Gazelle Accelerator program. In this sixth program, we are supporting 17 startups, and from the start of the project, we have in total supported 114 startups and SMEs, which are located in 18 countries in Europe. We have involved also from the start 25 industrial corporates in the Gazelle Accelerator program. So those corporates have provided us with manufacturing challenges in order to the startups and SMEs to answer those manufacturing challenges. We have involved also 13 European investors. We have provided also dedicated coaching and trainings for the startups and SMEs in order to really support them for their introduction and their first speech in front of investors and industrials. We have created 150 connections between the participants and industrials, so end users, and between the participants and investors also. And we have a non-disclosure agreement signature ongoing between the participants and the industrials in order to continue the discussion, the technical discussion, especially. We have also the EIT Manufacturing, which has invested in some of the participants of the Gazelle Accelerator programs. And we have also non-disclosure agreements which are currently being signed between participants themselves of the program, which want to gather their skills, their complementary skills, in order to offer a complete solution for the industrials. So we have a lot of following to do with those companies to really support them until the end. And so you can, if you are interested to look at all the startups we have supported, you can have a look to our Gazelle Accelerator website. All the startups are listed here with the description and their video pitch. And yes, if you have any questions, please do not hesitate to ask them in the chat or to look at our LinkedIn with the Gazelle Accelerator, or at our website with all the information. Thank you very much.
Thanks a lot, Anne. Thanks a lot for this presentation. Coming up next is IntoFlex, the project IntoFlex, and I'm sorry in advance if I butcher your name. I'll do my best. Presented by Christoph Ramsauer and Paul Scheuer-Goffer.
Sure, yes. So my name is Christoph Ramsauer. Thanks for the chance of presenting our project here. I'm with the Institute of Production Engineering of TU Wien in Austria, and as activity leader, we are in charge of the IntoFlex project, aiming for instrumented tool systems for flexible production. So the problems and issues we see are in modern day machining and milling processes. They require, on the one hand side, very high precision and surface quality, and on the other hand side, we have to have low failure rate and lowest price possible for the manufacturing costs. And especially the tools are very expensive in many cases. And producers have to balance for flexible production and high quality standards. So we see the need to monitor the condition of the process and the condition of the tool. And thanks to EIT Manufacturing, we were able to provide a solution for that. I can put it just in here into the camera. It's a smart sensorized milling head that was constructed with the partners of the consortium. These are milling heads based on the mechanical prototypes of company Volta in Germany, and they are sensing temperature and cutting force on the individual cutting edge and acceleration of the overall milling head. That was achieved by customized electronics, including battery supply, wireless data transmission that is based on Bluetooth, and all the electronics were encapsulated in epoxy resin to be resistant to the conditions we have in the milling machines, for instance, cooling lubricant, chips, dust, and oil. We are not having a single solution, but it rather provides a versatile solution, since the outer shape of the milling head as such is not changed, and the milling heads can be used for different kinds of industrial applications. Since they still have their standardized interface and mechanical stability, and they can also be used for automated tool exchange we are seeing in modern production machines. So with this solution, we can sense the process, workpiece, and tools condition. And that's not only for monitoring purpose, but it rather provides a deep insight also for the machine tool operator and gives chances for real-time capable adaptation of the machining process. So we can thus create several kinds of feedback loops and even address digital twin functionalities. So overall, this is not just a milling head, but it also addresses important things for society, leaning towards Industry 4.0 and Internet of Things, since these smart tools really do have a sensing function, and they help to get better, flexible, and competitive machining optimization, machining processes due to the data we gain. It also increases the attractiveness for the workshop personnel, since training of new personnel is easier based on KPIs and enables better know-how transfer. And it can also be used to retrofit existing machines, and as already said, provides a versatile approach, since as far we used it for mold making, production processes, energy, naval, and in steel plant applications. Thanks for the chance of presenting.
Thanks a lot, Christoph. So coming up next is the project LAMM, presented by Andrea Leone.
Good morning, everybody. Thanks for the chance to present LAMM Prodem. I'm here on behalf of the Professor Niccolò Cavina, who is not able to participate. So first of all, LAMM stands for Leveraging Competencies and Skills of Professional in Digital and Automated Manufacturing Process. LAMM project consists of 1-year project financed by ATM through its educational pillar. Our aim was designing and delivering a T-shaped professional education program with the most updated and innovative content for professionals employed in the manufacturing sector, specifically designed by high-level researchers coming from university and research institutions in Europe. The issue addressed is related to the automation and digitalization revolution, which has been taking place, which represent a great challenge for the manufacturing sector and its ability to rapidly and effectively update competencies and to introduce digital technologies towards more productive and eco-efficient manufacturing processes. Our project program is designed to meet different training needs within manufacturing companies, also for reducing intergenerational barriers of knowledge and skills. The program provides opportunities for different targets of professional to upskill and reskill. For junior professionals, such as those employed from less than 3 years in the company, it enables upskilling, accelerating the process of aligning skills and providing growth and professional development. For senior professionals instead, reskilling, integrating their skill with the most recent technologies available in the manufacturing sector. LEDAM training program is designed through a modular structure, which enables to access contents in a flexible manner through ATM Skills Move platform and allows to reconcile training with work. The training content is organized into 28 video crash courses of 15 minutes each, made available within thematic learning paths on 5 main areas of knowledge: advanced manufacturing, information and communication technology, innovation technology for energy saving and sustainability, quality control and safety, innovation and entrepreneurship for manufacturing. 5 additional storylines, which are learning paths of about 3 hours each, enable to have a look at how these theoretical competencies can be practically applied in the field, mixing specialized theoretical contents with example and case study, co-designed with the Lehman Partner Company as well. So, why is it so important for society? We believe that through upskilling and reskilling of professionals, the broader field of Industry 4.0, LEDAM increases knowledge of the benefits of digitalization and automation in manufacturing processes, and in providing energy efficiency through providing knowledge on greening and eco-efficient technologies. Furthermore, it integrates the 3 sides of knowledge triangle in reshaping competencies of the manufacturing workforce. The consortium is composed of 4 institutional partners who are in charge of designing and delivering nuggets, learning paths, and storylines: University of Bologna and Alma Mater Foundation from Italy, and 2 research institutions, INEGI from Portugal and Fraunhofer EAPT from Germany. LEDAM project also includes 2 industry partners, Marpos and Bonfiglioli, which are involved in training needs analysis, co-design of 2 of the storylines, and as beneficiaries of the training. A pilot of the training starts on November the 9th and will involve about 200 professionals of the manufacturing sector in Europe, enabling free access to training contents until the end of the project, December 31st. For any further information about the program and how to participate in the pilot, you can visit our website, or you can ask me anything for further information, any concern. I'm here to reply to answer. Thank you for your attention.
Thank you, Andrea. I think there has been a tiny little mistake when it comes to the fact sheets and the information. But thank you for this presentation. So this was for LEDAM and not LAM.
LEDAM.
LEDAM.
Correct.
So thank you for this. And now I will introduce you to Thiago to present LAM. Sorry for the confusion, but now here's your turn. Thanks a lot.
Hello all. No problem. These things happen every now and again. I'm glad to be here to speak about LAM project to you all. My name is Thiago Núncio. I'm part of FAN3D, the Portuguese partner for this project. This project counts with 4 partners: One3D, which is the technology provider, FAN3D and Guaranteed, which will act as demonstrators for the technology, and LMS, who will be being the manager for this project. In this case, the main objective of the project is to create a system that is able to provide the biggest deposition kit for WAM 3D from WAM systems for DAD art, as well as provide a tool that makes it possible to adapt WAM system to an existing robot. For this, it was developed a new end effector for the robot, which allows for twin wire depositing as well as a specially shielded environment in order to reduce the porosity. Through this, it was also developed the software, the WAM 3D software tools to optimize and process this new approach, and the life cycle testing tools were also created in order to evaluate the possibilities sustainability-wise for this approach. In the end, what will happen is that the deposition rates will increase due to the twin wire highly deposition rate. Because of this, also the CO2 equivalent emissions will be lower in comparison with traditional manufacturing. Because the reduced time, there will also be a cost reduction for parts produced through this technology. And also, in the end, two digital nuggets will be delivered in order to educate the possible interested people in WAM technology in the system. Through all of this, it will also be developed two different torches. There will be a TIG torch for using cold metal transfer, and a titanium torch through plasma, which will allow for a variety of different metals to be deposited using these approaches. Well, thank you for your time and for allowing me to teach you all about WAM project. You can always find more information on the website, in this case through WAM 3D's website or on our LinkedIn page.
Thanks a lot, Thiago, and sorry again for the tiny little mistake. Now it was supposed to be on Ledam's turn with Andrea, who just did his presentation before. You're all aware about this. And we will send you all the fact sheets at the end, so you will have access to everything and you will see everything. Just right now you can see actually the fact sheet for Ledam.
Okay, thank you very much. Thanks.
Yes. So don't hesitate to ask questions once again in the chat, and if you have any question for Andrea and about the program, and we will have the pleasure to answer you. To continue with the presentation, let's move on to LIF 4.0, presented by Massimiliano Annoni. Massimiliano?
Yes. Nice to meet you, everybody. I hope you can hear me properly. Okay. Yes, thanks, Loris. My name is Massimiliano Annoni from the Department of Mechanical Engineering of Politecnico Milano, and presenting here today to you the results and the purpose of our project LIF 4.0. And this project has the purpose of developing didactic material that can be useful for professionals in the machining field. With machining, we intend chip removal processes and in particular milling. In fact, SMEs in this sector, as also Gernot already said, are feeling some difficulties in digitizing their workflows related to the development of their machine cycles. And so even if they know that there are some tools from Industry 4.0 and even software like CAM, but even electronic catalogs for selecting the tools, they are feeling some difficulties in these applications. And so our purpose has been to develop and to help these companies, SMEs in particular, in order to guide them to use these tools, in order to improve their flexibility and efficiency in the machining field. And I always use this example where everybody knows how the recipes on YouTube, the recipes, the cooking one, are effective. So we have tried and we have developed a learning path with exactly the same type of approach to guide the professional user, that can be an operator or even a student or a newcomer in a company, in order to use such tools. And we covered all the paths from, as I said, even the machine selection, the tool selection, and also the parameter selection for defining a stable machining operation, and then also the CAM application. And the use of simulation software, some of them are proprietary ones, or we have also used the Breakout software in order to foresee the cutting forces and better test the machine cycle before going to the machine, and even the CNC setting. So we have this new learning path on skills.move in the trial version. And we have applied this learning path also in some live experiences like workshops. We have the last one for this year in Milan on the 25th of November, where we bring a real example of machining of a blanking die, where we will use such instruments. So the idea is to both have some didactic material that is available online, but we are trying to implement a flipped way of making courses where the learners can use these materials in advance, but then they can come to our laboratories and the laboratories of all of the partners in order to see in action what they have studied. The partners of these projects are, apart from Politecnico di Milano, Mondragon University, CTU in Prague, and also the Technical University of Darmstadt. And we have also an SME, Waterjet, that has been very helpful for us because it was absolutely strategical in order to test the material and in order to have the point of view of an SME using such tools. That's all from my side.
Thanks a lot, Massimiliano. Okay, so bear with us. We've been through half of the presentations, and now I am pleased to introduce you to Juan Carlos and Pauline Urbaneja for the program Malta.
Okay, I don't know if you hear me?
Yes, we can.
Okay. So thanks for introducing me, Loris. Good afternoon, everybody. As he said, I am Juan Carlos Antolin from Tecnalia. I am the activity leader of the Modern projects. And first of all, I would like to thank the opportunity to present briefly the project and its progress. The main objective of the project is to develop a flexible hybrid solution for the production of molds for big composite components using additive manufacturing technology with an extruder for pellets of high feed rate. So the problem addressed in this project is to extrude thermoplastic pellets for creating preforms of molds instead of machining welding from bulk metallic pieces for manufacturing molds. In this sense, a robotic hybrid manufacturing system will be used to create the molds preformed by means of thermoplastic materials. These molds preforms will be inspected, machined, and finished in the same cell in 2023. In this project, two RTOs participate, Tecnalia and LMs from Patras University, an integrator, architects, and two end users, Arnova and Sudlon Blades, one from aeronautic sector and the other one from wind energy sector. During the project, we have pre-selected materials in order to fulfill their specifications. One of these materials has been characterized after printing in some conditions. In parallel, the end user use cases have been designed and simulated under the specification of the respective cure cycles. Meanwhile, we have designed the flexible hybrid robotic cell, and after preliminarily commissioning in EIT's facilities, now the equipment is in Tecnalia. At this moment, we are continuing with the manufacturing of the parts of each pre-molds, and at the same time, a digital twin of the hybrid cell has been designed, monitoring and gathering all information or info about the process. In addition to that, we have designed a modern knowledge software which gathers information of three kinds of data. The first one, the data of the process, such as the set point and present values of the TCP speed, extruder speed, temperatures, and so on. The second one, the models and simulations of the designed mold preforms. And finally, the data of the characterization of the material tested at the temperatures in which the material will be used. In this case, the software gathers the information about mechanical and thermal tests. Mechanically, these tests comprise tensile, flexural, compression, and shear tests. And thermically, we perform tests to know the coefficient of thermal expansion, the specific heat capacity, and the thermal conductivity. Summarizing, during this first year of the project, we will have in operation the robotic cell for manufacturing the molds, the mold and knowledge software that gathers information of the process, mold simulation, and the real condition and the material characterization. And we will be able to have some printed preforms, taking into account the specific designs after frame simulation and using characterized material behavior. That will be validated after that by the end users. So thanks to the EIT, we will be able to print large mold preforms by means of direct extrusion of reinforced thermoplastics for high performance applications in different sectors. In our opinion, this project will contribute to reduce the energy consumption, the lead time, the material amount avoiding waste material, and finally, the reduction of the manufacturing and logistics cost, increasing the productivity. So that's all from my side. If you have any questions, you can contact me. Anyway, more info you can find under the QR code included in the present sheet or visiting our website.
Thanks for that, Juan Carlos. Coming up next, Daniel Knutel with the project Oscar.
Can you just wait for the slide maybe? Or? Okay. So thank you for the introduction. My name is Daniel Knutel and I'm a research engineer at Inspire. And today I will present you the EIT project Oscar, which is an abbreviation for optical scan and repair. And the project is conducted in close collaboration with the activity leader Prima Additive, the research entity Subsi and Inspire, and the end users IBM and Pozzo. And within the project, we are focusing on the problem of repairing. In particular, today, many metal components aren't repaired. It's not attractive or not convenient. And even if maybe only 1% of material is missing, the part is still thrown away because it doesn't satisfy the requirements anymore. And therefore, we developed or proposed a solution which consists of an integrated scanner, in our case, a structured light scanner, which is integrated into the machine. And I'm not sure if you can see if the resolution is enough, but on the right top you can see a little bit the process flow, which starts with the damaged part. And then based on the scanner, we can capture the actual geometry. And based on the actual geometry, you can compare to the nominal one to identify the defects and then plan the part program. And since direct metal deposition is also a process which, of course, as many processes can include some defects and process deviations, we simulate the process before to anticipate eventual defects or also to avoid just collisions with the part. And this enables us to, or enables the product at the end to more efficiently repair products or metal components. And this is in particular interesting because it reduces the engineering time and therefore it's also less costly for the entire production chain, and it makes it more attractive to repair larger or complex parts. And this is important also from an environmental perspective because it allows to decrease the energy consumption, but also, of course, the raw material utilization. And the integrated scanner enables also to increase the client satisfaction since we can control inline the quality during, but also at the end of the process. And thanks to EIT, it's possible to, we developed a fully commercial option, which can then be buy together with the Prima machines. And the results are important because it's an important step towards a circular economy, since we are enabled the repairing of materials or components instead of manufacturing them from scratch. And I think it's obvious that it's a little more convenient or less harmful for the environment. And the solution is, of course, since it's an automated repairing process, it's more efficient and it reduces the costs in terms of time, but also of material and energy consumption. And thus, at the end, it turns more attractive for industry also to use this solution. And the proposed solution was developed into industrial sectors and the automotive and tooling. And one startup is Adexis, which is also situated in France, is involved in this project because they generate CAM or the software for the part program generation, and we adapted it within this project for the 5-axis CNC machines. And we used a process called direct energy deposition, which is an additive manufacturing process.
Thanks a lot, Daniel.
Thank you for your attention.
Thanks a lot. So coming up next is the project PALA, P-A-L-A, which will be introduced by Sunil Bhosle. Sunil?
Yes. Can you hear me?
Yes, we can.
Yes. I'll just wait for the slides here. First of all, thank you for giving the opportunity to present in this forum. I'm Sunil Bhosle. I'm the Senior Manager working for Europe Supply Chain Innovation for Procter & Gamble. And what is PALA? PALA is basically palletized load, which is automatic loaded. Before going into the problem statement, I would just like to give a background. Today, for example, everyone orders from Amazon or any kind of retailer shop. We all do online shopping. Before that product reaches you, it has to be in a warehouse. In this warehouse, the product is basically then moved on a pallet. So pallet is basically a wooden form of a structure on which you move the product inside a trailer. So the problem which we are solving here is the last mile, how we call it, to put those products which are on a pallet inside a trailer, which today is done completely manually, which means you either have to use any kind of assistive device, which are pallet jack or any kind of movable guided vehicles, and you place those products inside those pallets. And in Europe specifically, this is a complete manual done operation. And what we are solving as a solution, together with our partners, which is BF, which is the solution provider, and BIVA, it's a research institute from TU Bremen, we are developing a mechanism to move these pallets inside different kind of trailers. As you imagine, in Europe environment, we have different kinds of trailers which moves those goods. It can be a rigid trailer, it can be a curtain trailer, refrigerated trailer. It depends on what kind of product is being moved, and every trailer has its own characteristics. And so we are developing a single integrated movable vehicle, to put it in a simple words, to move the load, which is the pallets, inside those trailers. So this is the end-to-end supply chain, which is done at the warehouse automation. And to put an economical perspective, from market research, until 2025, this industry itself would constitute to around $3 billion, which means the product movement from the warehouse to a trailer. This is an industry of automated truck loadings, which is completely manual today, given due to the high investment or the not available technology. Why is it important for the society? Apart from the economic benefit or the opportunity, 50% of the safety incidents across the warehouse are in the dock operations. Dock is where the trailers is locked and you load the pallets inside. It enables a higher throughput as we are talking about the increasing growth. Everyone from today's point of view is ordering more online, and this is increasing the demand. So it's a capacity constraint given in following years. And we want to increase the supply chain resilience. And what does it mean? It's the people who are moving these pallets has to be safe, and at some point in time we will not have so many people able to fulfill the demand which is occurring in Europe as a continent. So that's the importance of this project to the society. And especially here, I would like to thank EIT, who has enabled us to get closer to our dream, which is end-to-end touchless warehouse operations. And this we are delivering together with DF and Viva. And coming to the results and insights, so we are developing the system with a LiDAR-based system. So it's a vision-based in navigation. So imagine something like autonomous driving truck or a car, which is taking a load roughly around 3 to 4 tons. And you can have different kinds of loading, which means Europe itself has 2 different kinds of pallets. One is Euro and one is UK. Then you go in different geography. Then you have the US pallets as well. And then the biggest concern is also about the product damage, which happens during this move. So it's a reliable process, and together with this, we are solving the last mile of warehouse automation.
Thanks a lot. Sunil. Yes. Once again, I would like to remind you that the chat is here if you have any question for any of our guests, any of our presenters. So don't hesitate to ask all the questions you may have. Coming up next is the project Riemann, which will be presented by Tobias Skłodowski. So Tobias, the floor is yours.
Thank you very much, Louis, for introducing me. So I'm Tobias Skłodowski. I'm a researcher from Viva, the Bremen Institute for Production and Technology in Bremen, affiliated with the University in Bremen. And Riemann is about autonomous mobile robotics using open source components. So the idea is that you have probably a warehouse management system, as I was already mentioned in this pilot project before. There's also a need for upskilling operators, workers, and engineers. There's also Gernot and Massimiliano mentioned that project. And the idea is to spread more the ROS environment, which is still emerging with the ROS 2 version, to a more stabilized way to be used also in industrial environment. So we have also the fork ROS Industrial, which gives a lot of frameworks and plugins to use navigation tools and mechanism and algorithms to be applied on mobile robotics, which you can also use in warehouses. And the idea is to lift a little bit the burden of small and medium-sized companies which are using intralogistics mobile platforms, so AGVs, which are hardware locked or vendor locked and are not opened to be configured by themselves, to spread the knowledge about ROS and especially ROS 2 and didactic material we created for the SkillsMove platform. So in that case, we created 7 learning paths, which contains the basic functionality of ROS, how you can apply this on a mobile robot. And we are using as an example the small Turtlebot 3 robots you can see here on the picture right on the top. And we try also to emphasize that the advantage of using ROS is that you can apply it to many different robotic platforms. So even not only restricted to autonomous mobile robots, but also you can advance now to robotic manipulators, which are also presented or which are also then supplying now more and more ROS interfaces. The project itself contains 7 learning paths. So we have 2 basic or learning paths for operators or engineers who are not so familiar with programming or with ROS itself, or the frameworks, how they are conducted. And we have more 5 advanced learning paths which are then more on the advanced algorithms and learning paths, routing algorithms. And we are doing this project together with the CTU in Prague, with University in Tartu, with as activity leader, Arun Kumar Singh, and as an industry partner who helps us a lot to gather all the needs and also to apply or adapt this into blended workshops, Kumau, where we also conducted a physical workshop in October. We had also a physical workshop in Bremen in the BIBA Institute, also with engineers and students. And we are also planning to have 2 more workshops then in the end of November and beginning of December to try out and evaluate the missing gaps or knowledge which is needed for the operators and students and also engineers to conduct all the learning paths. Thank you very much.
Thanks a lot, Tobias, for your presentation. Coming up next, it's the project Sesam, which will be presented by one of my colleagues from EIT Manufacturing, so Lina Palmquist. So,
hello, everybody.
The floor is yours.
Yes, as Loris just mentioned, I am presenting Sustainable Steel Additive Manufacturing Project, which is called Sesam for short. It's quite a new project. It started in September this year. And the why of the project is really about sustainability, resilience, and innovative manufacturing. Additive manufacturing technology has obviously some key benefits, including faster route to market, better functionality, and lower environmental impact. And so a key challenge right now is integrating AM systems into production. So in terms of integration, it needs to be easy to use, simple to integrate into existing production flows, and yield consistently high quality materials, which is something that we are addressing. The project parties in this project, we're 6 project parties in all, including Alfa Laval, Boel Walder, University of Western Sweden, and Procada and Adaxis as startups. And EIT Manufacturing is the dissemination party for this project, which is why I'm here. But we also have an activity leader who is Robert Peterson, and he is the person to contact. Sorry, I muted myself. Yes, I saw that.
No worries.
Yes, and Robert Peterson is the person to contact then. In terms of the solution, it is working with a laser beam directed energy deposition with wire, which is a particularly promising pathway for the next generation of industrial production. The solution basically cuts lead time and also makes it possible to have larger metallic structures in place. And the project thinks that this can be very well integrated into current supply chain, and that it can result in significant returns on investment and also reduce environmental footprint, which is a major factor that the project aims to address. And basically, in terms of future results, because we don't have quite any results as yet since it's so new, but what the project hopes to achieve is showing that we can get return on investment shorter lead times and new business models based on the AM technology, as well as a lower environmental footprint, as mentioned. So as I mentioned, this is the start of the project. It's a 3-year project, and I hope by next year we'll have a lot more concrete results to show.
Thanks a lot, Lena, for this interesting presentation. Coming up next is Smart Flex Cell, which will be presented by Laurent Marty. So, Laurent, the floor is yours.
Thank you, Loris. Hopefully you can hear me. It should have been Professor Kovac from the Joseph Stefan Institute, but he could not make it, so I will replace him as a quality of technical coordinator of the project. So the project is quite ambitious. It is doing by 6 partners among Europe, from the north, Denmark and Lithuania, from the middle, from Slovenia, and from the south, from Spain. Denmark for proposing and delivering one of the important pieces of the project, which is hexapods, which are the backbone of the project for building flexible fixtures for assembly, machining and welding. Lithuania for making all the robot programming of the cell, Slovenia with the Joseph Stefan Institute for making advanced robot positioning system and also robot-aided configuration. Then Spain with Mondragon University for robot characterization and compensation of trajectories with robots. And also from Spain, where we have 2 use cases, CTAG for the automotive industry for welding body parts for different vehicles, and MMN Eldekin for machining knuckles for cars. This is knuckles. The issue we're addressing with the project is to add extremely flexibility in the production process by having a robot system cell which is able to both reconfigure itself. That means that the robot is preparing its own working cell by repositioning the fixture or the jig of the part to machine or to weld in a geometrical way. And the same robot is making also the operation like spot welding, machining, assembly, and different things. And the focus for us is on the automotive business, which is one of the key sectors in Europe, I will say, where the goal is to make production unit more profitable and adding more flexibility for also future production and prototyping of different things. So our solution is that we are building 2 setups. As you maybe can see on the small illustration, you cannot see the whole fact sheet, but I think that we will get it. So you can see a large spot welding robot for a car doors, where the robot here on this setup is able to change for different configuration by simply moving the hexapod to another geometry. And that's the hexapod behind me, this kind of small device, which has 6 degrees of freedom. It's a movable component, that means X, U, Z, and then rotating on this on axis, and is easily moved in all directions by the robot and to any position, of course, in a defined area. So the characterization of the hexapod for this kind of project is that it is a very accurate system, repeatable, and is very robust. And then the whole cell keeps the configuration inside for future operation if you have to go back to the same kind of operation. And the whole idea is to make the system easy to program and use, as the interface is quite intuitive. We can download the whole series of drawing from the CAD drawing for the part to produce inside the robot configuration. You can program everything offline to secure that you have made the right geometry, that there is no collision, and all the safety is in place. And the second setup we are running is a little more complex, as it combines flexibility of flexible fixtures and machining of parts. And you can see as this is a kind of part as connectors, where you have to make different kind of operation with drilling, milling, and things like that. So that makes us the robot is building the fixtures, also the jig as the other project, but is equipped with a spindle to make the drilling and machining on that. So we have to compensate for some possible deviation inside the system during the process because of forces and different vibration. So what we want to do for this kind of project is to keep the production process as long as we can in Europe. where flexibility is one of the key issues, and customization is the second one. That means that the industry has to react quickly to customer demand and be ready to change all the time. So it will generate, of course, for Europe, security of employment, safety, and profitability inside Europe, which I think is important. So our results, we are not finished with the project yet, but we have demonstrated one of the use case already. It's working at CTAG, and the second one will be made by the end of the project, by the end of the year. So we have improved our solution and demonstrate that the use of reconfigurable fixtures or jigs is a way for several processes to make them high flexible. That can be welding, that could be assembly, that could be machining, all these kinds. So we are supporting companies and SMEs that want to improve their production facilities by adding more flexibility. It's key fixtures to make it inside the company, to be a part of the industry 4.0, of course, and making the use of robots more understandable and obvious for the SMEs. So we are starting. Oh, sorry, I had to promote. We are making a spin-off out of the company, the Smart Flexel, which is based in Spain. So that's all I want to say. Anyways, thank you.
Thanks a lot, Laurent. No worries. Okay, so thanks a lot for this presentation and thanks a lot for those informations. Now coming up next is APMAS with George Siaterlis. I hope I pronounced it well. And please, the floor is yours.
Yes, correct. Thank you very much, Loris. Hello, everyone. My name is George Siaterlis. I represent Laboratory for Manufacturing Systems and Automation, which is the coordinator of APMAS project. APMAS project focuses on two problems in production line. The first one is related to the failures, to the unexpected failures that are occurred in the production lines, and it is a common knowledge that an unexpected failure provides high maintenance costs and, of course, stops the production. Moreover, manufacturing sensing, maintenance, and scheduling service working separately, and this leads to the source of disturbance itself. So, Project APMAS provides an end-to-end industrial IoT solution for unified predictive maintenance and production planning and scheduling in the manufacturing workplace. In particular, consists of four objectives. The first one is a predictive maintenance diagnostic component, a mature software component that's coming from previous project, as well as maintenance-aware production planning and scheduling component, and industrial IoT cloud platform for integrating the software components, and of course, a use case that is related to white goods industry, where the solution will be tested and evaluated. The contribution of APMAS is mostly related to the reduction perspective in general. By applying APMAS in production lines, a reduction in water usage and in general in pollution is observed. Furthermore, by predicting a specific failure, the maintenance costs are decreased, since that no other damages and other issues are observed. And of course, by applying APMAS in production lines, the number of defects are decreased at least 15%, according to some preliminary results that we have already applied. Thanks to EIT, we were able to improve, mature, test, and validate our solution faster in order to provide a unified solution in the market. In conclusion, regarding the main results and insights of the project, the first one is related to the maintenance-aware scheduling in production lines. app must provide a scheduling solution that is able to take into consideration maintenance and other activities. The next one is the sustainable solution based on Industry 4.0 standards. And the whole approach regarding the data part has been modelized and based on asset administration cells and enhance the interoperability of the solution. And finally, focuses on the reduction of the wastes and the costs in production line. For any further information, for any question, please don't hesitate to contact our activity leader, Mr. Kosmas Alexopoulos, or visit our social media and of course our website. Thank you for your attention.
Thank you, George. Thanks a lot. Coming up next is the project Verso, which will be presented by Joseba Bilbatua. I hope I pronounced it well.
Yes, right.
And so the floor is yours.
Okay, so thank you very much. Could you please confirm that you can hear me?
I can hear you properly.
Okay, but I cannot see my screen, which the picture. Okay, now.
You don't have to share it. We share it.
Okay, no problem. Okay, so first of all, I would like just to thank the EIT Manufacturing for giving me the opportunity to present you the Verso project. Verso stands for Versatile Clamping Systems oriented to machining flexible parts. And just to understand the concept under Verso, please have a look on the small picture you see on the right top corner of the screen. You can see robots, but this is not the important part of the Verso approach. But check what it seems to look like a small lamp that is connected to the part. I guess you can see it. This is the Verso solution. So what's Verso? The main problem that Verso technology wants to solve is how to reduce or to eliminate vibrations when machining slender parts or slim parts. So as you can imagine, when the machine tool is cutting a slender part or a thin part, the cutting forces introduce some dynamic vibration on the parts, and this dynamic vibration could, from one side, reduce the quality of the components, introducing, for example, chatter or other desired errors, and additionally, this vibration can reduce the tool life. So in some sectors like aerospace or big mechanical engineering sectors, it's mandatory to reduce or try to reduce these vibrations. So in Verso, we arranged a consortium of 6 partners. The project is being coordinated by Mondragon Corporation as the main leader. I am the coordinator, and we have Solaluce is a Spanish machine tool manufacturer, and is the main business owner of this solution and responsible of exploiting and offering it to the market. PTW and IDECO are the 2 research centers developing the actuator and the electronic behind the solution. And IDEC and Stune are end users. IDEC is from the aerospace sector, Stune is from the mechanical engineering sector, and they are providing us the pilot scenarios where this solution is going to be tested and validated. So the Verso technology, as I was mentioning, is based on electromagnetic actuators and sensors that are able, from one side, to measure the vibration, to decide what kind of counteract or force should be made, and in which direction and in which intensity, in order to eliminate the vibration. So we have to solve several challenges for producing this solution. First one was to to extend the range of materials in which the actuator could be clamped, because at the beginning we started with ferromagnetic materials, and the clamping was made by a magnetic solution. But when you are machining carbon fiber, you cannot use a magnetic solution. So we solved this problem developing a vacuum clamping. After we introduced the 4 applications that are able to, from one side, make the damping, this verso damp. Verso relief is another application that is able to eliminate the residual stresses in the parts. Verso check and verso monitor are 2 apps that controls how the manufacturing process is going on and what is the change on the actuator parameters need to be introduced according to the manufacturing process. This solution is very important, not only for the aerospace and for the mechanical engineering sector, but there are many other sectors where these vibration problems are needed to be solved. And from the point of view of the worker, of course, this system increases the safety and it makes the working area more, let's say, ergonomic and not so requesting on effort by the operator. Yes, I am just finishing. So you see the main results that we have produced based on the different kind of actuators, the apps. I have to say that the system is being validated nowadays. We have already sold several systems in several end users. So the result is going to be commercialized next year and offered to the market as a good innovation in the machining of the part. Thank you very much.
Thanks a lot, Joseba. Okay, so last but not least, now it will be about the strategic regional innovation. The presentation will be done by my colleague Veronica Rodriguez from the REES team. So Veronica, welcome and you have the floor. Thank you.
Thank you so much. Hi all. Well, I am Veronica. I am the REES Operations Manager within EIT Manufacturing. I'm going to talk to you about a cross-kick project that we are participating at. Basically, as you might know, cross-kick means that this project is developed by different knowledge innovation communities. So basically, in this one, we are participating with all the other KICs. So Euromobility, health, food, climate, digital, and so on and so forth, raw materials. Within this project, we are having several initiatives, several work packages, but I'm focusing the presentation on one of them. You might already know a pre-accelerator program called EIT Jump Starter. Basically, this is a pre-accelerator program, cross-sectorial, that we are running together with the other KICs, as I was saying. And this is the main flagship of the cross-kick project. With this pre-accelerator, basically we are targeting idea holders, early stage innovators who are mostly technical people, scientists, researchers, students that have a technical idea, but they don't really know that much about entrepreneurship. So basically, this is a one-year program in which this kind of public is applying through an open call, and we accept 30 teams per category. So in this case, at EIT Manufacturing, we will be working with 30 teams through the year, and they will be going through different trainings, mentoring, and exercises in order to develop the entrepreneurial skills that they are somehow lacking, but that they are interested in because they want to bring this technical idea to the market. So, well, basically, I can tell you that this is the 3rd edition that we are running this pre-accelerator program. We have supported several startups already. We have really success stories coming from the program. Actually, I don't know if you attended today to the leaders final competition, but the winner is a former Jump Starter alumni from EIT Manufacturing. and she has gone through different programs at EIT Manufacturing, and she has been developed herself. But this was kind of the jump starter, the kickoff of her in the entrepreneurial world. So the idea is that we would like to keep continuing this activity. This is open for all RIS eligible countries. We collaborate with our RIS hubs partners, the other EIT communities, so meaning the other KICs, but also their hubs. So there is a huge, large network involved in this program. And thanks to that, we are having like the best experts and best training developed for the teams that are joining to the program. So if you are interested, it will be open again for next year. There is already a pre-registration in the website. And yeah, well, for us as EIT Manufacturing, also to mention that our main goal here is to help to create new startups, new jobs, and somehow boost the manufacturing entrepreneurial mindset among Europe. So yeah, that could be that in a nutshell. And if you have any questions, I will be happy to answer them. Thank you.
All right, thank you, Veronica. So this was the last presentation. We received one question for Laurent from Smart Flex Cell. So the question is, have you tested the Hexapod as a workpiece holding device in mining? And if so, have you dynamically characterized it to check if it introduces compliance to the fixturing system? Thank you.
Yes, thank you.
It's a bit technical.
It's very technical. And it's from Massimiliano. Thank you, Massimiliano, for this question. I tried to answer on the chat, but as I understand, you cannot get the answer. That's the goal of the project, exactly, with the machining, because on the machining, so we are going with the Hexapod to maintain this part like that, and we are going to make some drilling and some milling on the part. And for this application, so on the top of the Hexapod to hold the part, so we are placing torques and force sensors. And one of the Hexapod, we will have also position feedback to know exactly where the Hexapod is. And we will measure all this. And the whole idea is, together with Mondragon, is to adjust the robot trajectories according to the information we will get from that. So hopefully it will work. I'm not so afraid with the other project with the welding. I think it's not an issue, but with the milling and drilling, you are right, Massimiliano, that's an issue. So we will see. As I say, the Hexapod is very robust as a system. We have the clamping, which is quite good. We will see which kind of precision. But the whole idea is to have a precision of 0.1 millimeters or something like that. I hope I answered to your question, or we can discuss together if you want.
Thanks a lot.
Yeah, thank you, Laurent.
You're welcome.
All right. So this is the end of the session, and thank you very much for your participation. Thanks a lot for all the presentations. It was really interesting. I hope you learned a lot of interesting things, and that you are interested in our projects even more than you were before joining us. So I wish you a very pleasant rest of the day, and for those who did not eat, je vous souhaite un très bon appétit. Have a good day. And